We are in the process of learning about pointers in our series on C programming. In this lecture, we are going to learn about pointers as a function argument, meaning how can we pass a pointer as an argument to a function. We have already covered function, we have already covered array, we have also covered pointers, the basics of pointers. So today, how to pass the pointer as the function argument. Okay, so in this lecture, what are we going to cover is broadly three things. First of all, we are going to learn about call by value and call by reference. In one of my previous lectures, I've already discussed about call by value and call by reference, whose link I'll be providing in the description. But today, again, it's a revision of the same concept, call by value and call by reference. It's very important. And how to pass pointer to a function, that's the main point. How can we pass the pointer as an argument to a function? And we are going to do some examples as well. And we are going to do some logic building, wherein we are going to solve our problem and then we are going to code the same. Okay, so let's get started. So first of all, let's learn about what is call by value and call by reference. Okay, so the example that we are trying to take here is swapping two variables using a function. So first thing that comes in your mind is, what is swapping? You know, swapping is interchanging the position of the values that is variable is holding. Like for example, let's take these two variables int a equals to 5 and b equals to 10. Right? Now a is holding the value 5 and b is holding the value 10. Now if I perform swapping, a now should hold the value 10 and b now should hold the value 5. So we're interchanging the values that the variables are holding. Okay, that is what is swapping, also called as interchanging the values of the variable. Okay, now let's take this example. Whenever I write int a equals to 5 in the memory, a would be taking some space, right? Let's say a is taking the memory address of 1000 and b is taking the memory address of 2000, and I'm assigning a equals to 5. So inside the address 1000, the value 5 would be stored, and inside the address 2000, which is for b, the value 10 would be stored. Right? This is the condition before I perform the swapping. This is how it looks like. Okay. Now if I perform the swapping operation, I perform swapping. So we have to design the logic for swapping. Okay, we are going to do that in this lecture. So I perform the swapping. After the swapping, what should happen is a should hold the value of b. So that means in a, that is the memory address 1000, the value of b should come here. So a should now be 10, right? So the b's values is stored in a, and b should have the value of a, so b should have 5. Now if I reach to this condition, I say that I performed swapping. Okay, so I've interchanged the values that the variables are storing. So this is what swapping is. I hope you have understood what swapping is. Now we are going to devise our own logic for swapping variables. So let's take the same example. A is having the value 5, b is having the value 10. Now how do I perform swapping? Okay, so to understand this, let's take an example. Let's say in my hand I have two pens. I have a digital pen here, right, and here I have this red pen, right? So this is stored in in the left of my hand I have this digital pen, in the right of my hand I have this red pen. If I want to swap this, that means in the left hand I need to have a red pen, right? In the right hand I need to have a digital pen. How do I perform this? Right? Now for this you have to assume that, you know, a hand can store only one object at a time. Okay, so my left hand can store only one pen at a time, so I can't put both the pens together, right? Similarly, the right hand only can hold one pen at a time. Like the variables, you know, the variables can hold just one value at a time, right? That's the concept. Okay, so I'm assuming that my hand can hold just single pen at a time. Okay, so now how do I swap these two values, right? So it's difficult to just swap if I don't have any third place to keep my pen somewhere, right? So let's say I keep this pen somewhere. I need to have some location to keep this one of the pens, right? So I don't have a third hand right now. So what I'll do is I'll just keep this pen, you know, maybe I'll keep it in my ear like this. Okay, if it fits. Yeah, it fits, right? So now this is empty, right? So I put it here. So this is my temporary location. I've put my red pen there. So I'll just transfer this digital pen to the right hand, and from my ear I'll just catch hold of this and put it in the left hand. Now I've done the swapping, right? So the intention here is that we will be needing one third variable which will help us in swapping. So let's say here the third variable that we are taking is C. Okay, C. So what I'll do first of all is I'll just write down the steps here, right? Step number 1, what I'll do is, let's say you copy A to C. I'll copy A to C. So A was 5. Now 5 is copied to C. So this would be 5. Now C is holding the value 5. Now as I've already copied the value of A in C, I can safely copy B into A. So first I did this one. I copied A to C. Now I'll copy B to A. Okay. So step number 2, I'll copy B to A. Right? So if I copy B to A, previously A was 5. Now if I copy 10 to A, so this 5 would be now replaced by the value 10. Right? And finally what needs to be done is, last of all, third step is I need to copy what? I need to copy C to B. So I need to copy C to B. Right? So 5 would be copied to B. So there was 10 in B. So that will be replaced by 5. Now you see the values are swapped. Previously, before performing swapping, A was 5, B was 10. Now after performing this swap, now A is 10 and B is 5. Right? So these are 3 steps that we do. So how do I write copy A to C? How do I copy A to C? How do I write a code for this? Copy A to C. So it should be C equals to A, right? So I'm copying A to C. Copy B to A. So this will be A equals to B. I'm copying B to A. The right hand, the value at the right of equals to would be copied to the left hand side. Okay, so A equals to B means A would be as equals to B. That means B would be copied to A. Okay, and copy C to B. So it will be B equals to C. So if I perform these 3 steps, that is C equals to A, right? A equals to B and B equals to C, I am actually done the swapping, right? For this, I'll have to also create this temporary variable C. So at the start, I'll have int A equals to, C int C, and obviously A and B should be declared as well. Okay, so this is the logic for swapping. You have understood the logic for swapping. Now the problem is that we have understood the logic, right? So it's very important to first of all understand the logic. Once the logic is done, now we are going to perform the swapping using a function. That's the problem, right? We are going to put this entire code into function, right? So the logic is quite simple, right? We have to create one variable C, right? Let's create this variable C, right? And I write C equals to A. That means I'm copying A to C. C equals to A. So C should be 5, right? And A equals to B. So B would be copied to A, right? B would be copied to A. So this would be nothing but 10. And B equals to C. That means C would be copied to B. C would be copied to B, which is 5 is copied to B. So this is 5. Swapping is done, right? So this entire thing is my logic, right? So how do I put this into a function? It's very simple, right? If I have to put this into a function, I'll have to, first of all, a function should have some, like, what is function, right? Function should have some input and some output, right? In this function, the input are 2 values. I need to have A and B as an input, right? There's no return anything. I'm not returning anything from this function. I just have to perform this swap. Okay. So let's say the return type is void. I'm returning nothing. So I'll write return type is void. Name of the function is swap. Right? I take 2 arguments to input A and B, int A comma int B, and this is the logic. So this entire thing is the function to perform swap. Name of the function is swap. It takes 2 arguments, integer arguments A and B, integer parameters A and B. It returns nothing, and the logic is these 4 lines. First, create one variable C. Then you perform these 3 operations that will do the swapping for you. Okay. Before we go ahead, let's try to code this. Okay. Let's try to see if this works really well or not. So this is the file that I've created, swap.c, to perform swapping. So I need to perform swapping using a function. So first of all, let's define the function to perform the swapping. Let's have a header file first of all. stdio.h, right? So as we have already seen, the return type for the swap function was void. Name of the function was swap. It takes two arguments, let's say int a comma int b. Okay, and the logic was quite simple. We have already discussed. First declare the variable c, then you write c equals to a. That means I have copied a to c, right? Now as the value of a is already copied, I can use a, so I can write a equals to b. I'm copying b to a, and then finally what I do is I'll have to copy in b, I'll have to copy c, right? That's how the logic is. Okay, so to use this, what I'll have to do is I'll have to write a main function, right? So I'll write void main, okay, and just open the bracket. Okay, now what you do here is I'll have to first of all, because the input should be taken in the main function, right? So let's take two input in a comma b. So this a comma b and a comma b in the swap function are totally different variables. Okay, they occupy different memory. Okay, now a, b in the main function are the variables local to the main function, so only main function has the access of that, and a, b, the parameters in the swap function is local to the swap function, and only swap function has the access to that. Okay, so I have created these variables a and b. So let me assign a is 5, okay, and b as 10. So assigning the values to the variable I'm doing in the main function, right? So let me first of all, print the values before the swap. Before swap, what is a? Before swap, a is, let's say, %d, and b is also %d, new line, a comma b. Okay, this is how I do it. Okay, this is before swap. Okay, now I call this swap function. I'll just write, how do I call this swap function? Okay, so how do I make use of this swap function? This is called as calling a function. Okay, so I'll just write calling a swap function. Okay, how do I call? First of all, I have to give the name of the function I'm calling the swap function. So in the bracket, I'll have to give the variables that I'm passing without giving the data types. I just need to pass the values. I can simply write 5 comma 10 as well, because here I'm already created the variables a and b, so I'll write a comma b. Okay, so what happens is it is going to now call the swap function, right? And the value that I'm passing from this swap function, line number 19, this a would be copied to this variable a. So the value would be copied. This is called as call by value. Okay, similarly this b would be copied to this variable b in the swap function. Okay, now after swap, let me print how it looks like. Okay, so I'll just paste this code here, and I'll write after swap. After swap, the value should be changed, right? So let's save this. Okay, now let's try to compile this code. gcc compiler, okay, swap.c. Okay, so what is happening here is some implicit warning is there. Print, okay, sorry, it should be printf, right? It's printf, it's not print. Okay, so because sometimes I do Python coding, so confusion happens. Okay, so in Python you just have print, not printf. Okay, that's the reason I made this mistake. Anyways, no issues. Compile it again. Compilation is done, right? Let's try to run this. exe before swap 510, after swap also 510. No changes, right? That means it could not really swap the values. What is the issue? What is the problem? Right? Let's try to understand what is the issue. Why it could not swap? Although our logic is okay, why it could not swap? Let's see it. Now to understand why it could not swap, I've taken the same program here, right? In the main function we did this. Okay, we have created the swap function here, right, which performs the swapping. And in the main function I have called this swap function. This is called as function call. This is called as function call. Okay, I'm calling this function, but I'm passing the values. So this is called as call by value. A and B are values, right? A is 5 and B is 10. So I'm passing the values. Okay, so in the main function will have its own memory, right? So let's say in the main function, because the function starts, the C program starts executing from the main function. So it starts executing from the main function. It comes to this int a equals to 5, b equals to 10. So it will occupy a space. A is having the value 5. Let's say it occupies the memory location 1000. Okay, and B occupies the memory location 2000. I'm assuming this, and B is having the value 10, A is having the value 5. Now in this line, I'm calling the swap function. So this is going to call this function swap. Okay, and it is going to pass the value A. So this value A would be, you know, it will be copied to this variable A. Now the int A in the swap function, now swap function will have its own memory. So let's say that A in the swap function is having the memory 4000. Okay, and in A, this the variable A having the address 4000 will have a copy of the value that is being passed. So it will be having the value A, which is nothing but 5. So this 5 would be stored in A, but this A is a different A and this A is a different A. A in the main function is having the memory address starting address 1000. A in the swap function is having the starting address 4000. There's a difference. Okay. Similarly, B is copied to the B in the swap function. So let's say in the swap function, B is occupying the memory address 5000. In the memory address 5000, the value 10 is copied. So this is how the copying is done. Okay. Now what I've done here in the swap function is I've created one variable C. So what is C? C is a variable, right? Int is a variable. So let's say it occupies the memory address 3000. I'm assuming this. Okay. C equals to A. So C would be A. So C would be 5. A equals to B. So now all these changes are happening in the swap function. A equals to B. So B would be copied here. So this would be 10. And B equals to C. So this would be 5. So the values actually changed, right? But why we could not get the output? Now values are changed in the swap function and not in the main function. So these are our main variables, right? So what we did was we were trying to print the value of A and B. So before the swap, A and B in the main function is 5 and 10. After the swap also the A and B in the main function is not changed. Because we are passing the value, the values are changed. The values are changed and those values are changed in the variables that is local to this swap function, right? That main does not know about those changes. But this does not work here, right? We actually want the changes to be done because swapping means swapping the original values. Whenever I say swap these 2 pens, I mean swap these 2 pens, not the copy of these 2 pens, right? So swapping should happen in the main function. So how do we achieve this, right? For this we need to do call by reference. What if we could pass the address of the variable instead of passing the value? Reference is nothing but the address. Okay, if I pass the address of A to the swap function, if the swap function is having the address of A, it can immediately do the changes, right? So that's what is call by reference. So what we do in call by reference is there's a small little changes in call by reference. This is the function that we have already done which did not work, right? The swap function and the main function. So what we do in call by reference is instead of passing the value A and B, I'll pass the address of A and address of B. So I'll write int, so sorry, here in the swap function, in the main function part, you see swap, I'll pass the address of A comma address of B. See, I'm passing the address. So these are the addresses. So this is called as call by reference. If I'm passing the address, I should have the variable that could actually hold the address. So what is the variable that can hold the address? I need to have a pointer variable, right? So instead of this int A comma B, I'll have to change it here and make it as a pointer variable. So let's say the first address, this address of A is stored in int star PA. This is the pointer, okay? PA, there's a pointer to A, int star PB. Okay, so this is how I actually take the addresses, right? Now I create, so that means what I've done is I've created one pointer variable. PA is a pointer that can hold the address. Let's say PA is occupying the address 4000. PB is one more pointer. It can hold the address of an integer variable. It is occupying the address 5000. Now PA and PB are local to whom? They are local to the swap function. A and B are local to the main function, right? I create one variable C. I create a variable C, okay? And C, let's say it occupies the memory address 3000. Now how do I perform this swap? Now I can't use C equals to A, right? So first of all, let's see, whenever I say ampersand A, right, ampersand is 1000, so 1000 is stored in PA, right? Ampersand B is 2000, so 2000 is stored in PB. So that means we can say that PA points to A, PB points to B, right? So if I want to really get the value of A, what do? I can use the indirection operator. If I apply star on PA, it will go to this address 1000 and get the value, right? If I want to get the value of A, what I have to do is I have to write star PA. I have to write this as star PA. In the A, I'd like to get the value of B, right? So I have to write here in the A. So what is A? If I want to get access of A, star PA is equals to star PB, right? And star PB is equals to C. Star PB equals to C. Star PB equals to C. Now let's see how it works. Okay, I'm going to work on this. So first of all, C is created, this variable is created, right? This box is created. Now I have C equals to star PA. Star PA is 5. So 5. So it could now see swap function could actually access the values of the variable in the main function, right? Because it is having the address of that variable, right? That's the advantage of a pointer, right? Now star PA is 5. Now 5 would be stored in C, so this would be 5, right? C is 5. Now C is local to the swap function. Now I write star PA equals to star PB. What is star PA? Star PA is A is equals to star PB. Star PA is A, this one, that is 5, equals to star PB. Star PB is 10. So 10 would be stored in A, that means, right? So this is 10. Now swap function could modify the variable A. Now star PB equals to C. Star PB. Star PB is nothing but this 10. Here the C should come. C is 5. So this would be 5. Now see, before swap the values were 5 and 10 for A and B respectively. After swap the values are 10 and 5 for A and B respectively. So this is called as call by reference. Here I am passing the, what I am passing? I am passing the pointer as an argument to a function. Okay, let's try to demonstrate this using our code. Now let's try to modify this code to make it work for call by reference. So instead of A, I'll write int star PA. This is int star PB, right? So in C, C equals to star PA, and this is star PA equals to star PB, and this is star PB, star PB equals to C, right? And here instead of passing A and B, I'll have to pass the address of A and address of B. So this is called as call by reference. Call by reference because I'm passing the address. Okay, let's try to compile this code and see what happens. Let's clear this screen. Okay, it's compiled and execute. See, before swap A is 5, B is 10. After swap A is 10 and B is 5. This is call by reference. Now you have understood how to pass a simple scalar variable, right? The variable that cannot be further divided as an argument to a function, right? As a pointer to a function, as a value to a function. How to do call by value and call by reference. Now let's take the same example, but we are going to do this on an array. Array is a vector, right? We have already discussed this. It's a vector quantity wherein it's a collection of multiple objects together, multiple, let's say, integer values together, if it's an integer array, right? So the problem here is the sum of elements in an array using a function. So how do I find the sum of elements in an integer array using a function? So let's say how to devise the, first of all, let's discuss the logic for the same. How to devise the logic for the same. So first of all, in the main function, what we do? In the main function, first of all, we'll have to have one array. So we have to take the input for the array. Let's say the array is A, and the input for the array will be taking the input from the user, let's say. So let's say the array are 5, 8, 2, 3, 6. So there are 5 elements, let's say. So size of the array should be decided in the main function. The values in the array should be taken, the input should be taken in the main function, right? And the main function should call a function to perform the sum. Main function is not going to do the sum because we are going to do the sum using a function. That is the requirement. So let's say we are going to write our own function to perform the sum. Okay, so if this is a function to perform the sum, because I have to write a function, right? So function should take some input and give you some output. If this is a function to perform the sum of array, so let me write this as sum of array, the name of the function, right? What is the input for this function? Input would be obviously the array and the size of the array. So here the array is this one A, which is 5, 8, 2, 3, 6, and this sum of the and the size of the array, here the size is 5. There are 5 elements in this array, right? So if I pass this, I'll have to do something, the logic here in the sum function to perform the sum and display the sum. So the output, the return type should be the sum. Sum is of integer type. So now here because I'm calling this function, so I have to pass the array to this function, right? Because if this function has to take input, it has two inputs. One of the inputs is the array. So how do we pass the array to a function? We have already discussed this in one of the previous videos, but again, it's a revision for you all. Okay, so to pass the array, you just have to give the array name. It's very simple. Okay, so let's say your function is like this, it returns the integer, right? Because we have seen the function should return your integer number, the sum, the final sum. So let's say sum array is the name of the function, right? It takes an array. So int, let's say A is the array. No need to provide the dimension. If you provide, it's okay, right? It's well and good. If you can give the size, or you can skip giving the size as the argument to the function, and it should have the size of the array. See, two inputs, array and the size. So this is the array and this is the size. Okay, it returns the integer value, which is nothing but this sum. It returns this sum. Okay, and we have to find out the logic for finding the sum. Let's say the array is already given to me. This is the array A, right? Now array is going to have the indexes, right? Starting from index 0, 1, 2, 3, 4 up to index 4 if the size is, if n is 5. If n is 5, the index will range from 0 to 4. So if I have to sum the elements, what I do is I have to run a loop starting from index 0 up to index 4, catch hold of the value, add it to sum and get the sum. Okay, so let's say first of all I'll have this variable sum, which is initially the sum is 0, let's say. Okay, I need to have one more variable I for running the loop. So how do I run the loop? For I equals to 0, 0 because the first index is 0 and the last index is less than I less than n, up to 4 it will go, right? And then I plus plus. So what I do inside the loop is I'll just make my sum is nothing but the previous sum, that was 0, plus the value at index I, ai. So this is how you do the sum, and finally after the loop you will have to return the sum. This is the entire logic, right? So the question is, will it work? Now let's try to see if it works or not. Let's try to demonstrate this by writing a program quickly. Okay, so this is where I'm going to write my code to perform the find the sum of elements in an array using a function, right? So let's write this header file first, right? Has include stdio.h, and then the main function, let's write int main. I could write also void main, no issues. Okay, so if I'm writing int main, I have to return 0 at the end. Okay, so in the main function, what do I do is I'll have to first of all have the array. Let's say the array is arr of size 5, for example. Okay, and let me just assign the values here itself. Let me not take the input from the user. 45, 23, 67, 56 and 33. Okay, these are the values. And how do I find the size? Let's give the size n as 5. Let me fix the size here itself. Okay, now I know that the size is 5. Now the main objective is to find the sum, right? Find the sum of elements of array arr, right? And display it. So I would like to achieve this using a function. So I'll have to write a function here, right? So I've already discussed the function that is going to perform the sum is going to return me the integer value, which is the sum. And let's say the name of the function is sum array. It takes an argument, right? The array. So if I'm to take the array as an argument, what I have to give the array name that you want, right? And the subscript. Okay, the size is not necessary. If you give it, it's okay, but it's not necessary. And you give this size. Let's say the size is size. Okay. Now, if this is the thing, what do I do? Here is the logic, right? We have already discussed the logic. I'll be needing a sum variable which is initialized to 0, and also I, which is initially nothing. It will be 0. I would be 0. I is for the index of the array, right? So what I do is I'll have to run a loop for I equals to 0, I less than n, I plus plus. Okay. And now the logic. How do I find the sum? Is sum is equals to previous sum plus a I. Okay. Or I can write sum plus equals to ai as well as a shorthand of this. I can write this as a shorthand like this also. Sum plus equals to ai. The same thing. It's a shorthand for the same thing. Okay. Anyways, I find the sum in the loop. It'll keep on running. Get the element, put it to sum, add it, get the element, put it to sum, get the element, put it to sum, and finally it will create the sum for you. Once that it's done, you return the sum. Okay. So now the question is how do I pass the question is how do I pass the array as an argument to a function? Now this function is taking the array as an argument, right? How do I call this function? Now here I have to call this function. So because it is going to give you back something, so I'll have to store that somewhere, right? So I'll write that in the ans variable. So I'll write answer is nothing but, what is the name of the function? Sum array, right? Sum array, this one, sum array. I have to pass, first of all I have to pass the array. How do I pass the array? Just provide the name of the array. Name of the array here in the main function is arr, right? If I pass arr, it is actually going to pass the array to the function, right? And the size is n, right? Now I print the answer here. Sum equals to %d, right? And I have to write comma ans. Okay, so this is done. Let me compile this code, clear the screen, gcc pointer function argument.c, and so again this is printf, not print. Okay, printf. Okay, so compile it again. Less than n, so this is not less than n, this is less than size, right? The variable here for the size is not n, it's size. Okay, and this is done. So compilation is successful now, no errors, right? Now sum is 224. I'm getting the correct answer, right? So now what is happening now? This is how this is working is you have to understand. Okay, now here you see the array is 45, 23, 65, 56, 33. Okay, let's say the starting address of the array is 1000, let's say, right? So the addresses here for the array is 1000 for the first element, right? So let's say the array integer takes 4 bytes, so 1004 for the second, right? 1008 for the third, 1012 for the fourth, and 1016 for the fifth. Now here you see I'm passing the array arr. We have already discussed in my video wherein I talked about pointer and the array. I told you that array name itself is the pointer, is a constant pointer, right? Whenever I write arr, it actually does not refer to the entire array. It refers to the starting address of the array. Arr is nothing but 1000, right? So it is actually passing the address of the array. So whenever I write arr, it is not passing you the entire values one by one. It's just passing the base address of the array, which is 1000, right? So 1000 is passed to this array to this function sum array. So in the sum array, now here you're actually having the access of what? You're actually having the access of this array arr. Okay, so this is call by value or call by reference. We call it as call by reference because I'm passing the reference. Array name itself is a reference. Okay, so this is how you pass the array to a function, right? Now this itself can be called as we are passing the reference or we are passing the pointer, right? Arr itself is a pointer, isn't it? Or we can also see that we are passing a pointer, right? So passing the array as an argument to a function we have already seen. How to pass a pointer as an argument to a function? right? So if I want to pass the pointer, let's say I create a pointer to this array ARR. I create one more pointer, let's say int star PA. Okay, star PA is nothing but the address of the first element in the array ARR 0, right? See, star PA is what? PA is a pointer. It is pointing to the first element in this array. So PA and ARR both are 1000, right? PA is also 1000 and ARR is also 1000, right? So instead of ARR, can I also pass PA here? I can also pass PA, right? Let's see if it works fine or not if I pass PA. Okay, let's try to compile this code. Let's try to compile this code. No issues. Run this. Answer is correct. It works fine, right? Now what if here, instead of doing this, I take this as a pointer here, like this. Instead of A, I write int star, let's say P A, or I can write it anything like PA or let's say PB. Okay, so int star P, let me write int star PB, no issues, right? So instead of AI, now I can write, right? How do I write this in a pointer notation, right? How do I write AI in pointer notation, right? AI in pointer notation is star of A plus I, right? So I could write this as star of A plus I, but I don't have A pass. I'm passing PB, right? So star of PB plus I, star of PB plus I. Okay, so let's try to see if it works fine. Okay, compile this code and execute this. It still works fine. Okay, so in this lecture we have learned, how to pass the array as an argument, right? How to pass the array as an argument, how it actually works, right? So you can pass the array name, which itself is a pointer, or you can pass a pointer to the first element, or you can create one more pointer wherein you can assign, like we have done it here, we have assigned the address of the first element and pass that pointer, right? So this is how it works. And how do you do this in the function? You can take it in a function, you can take it as an array, okay, because that will be treated as that will be having the copy of the address of what is being passed, okay? Or you can also create a pointer like this, okay? So this is actually, whenever you are passing the array to a function, it is called by reference. When you pass a simple value to a function, it is called by value. Here also you can call it as a call by value itself, but the value here is the address, right? If you call it as call by value, it's okay. You call it as call by value, but the value is what? The address, the base address of the array. Okay, so this is more or less that we wanted to cover in this lecture. So in this lecture, what we have done is we have first of all discussed about call by value and call by reference. We have seen the detailed example of call by value and call by reference by taking an example of swapping two variables, right? We have seen what is the disadvantage of call by value and how that can be overcome using call by reference. And then we have moved into this problem of finding the sum of elements in an array using a function, right? We learned how to pass the array to a function, right? And we are passing, whenever you are passing the array to a function, that is like you are actually passing the base address of that array to the function. So that is called by reference. We have also learned how to take in the function, how to take how to capture the base address that is being passed by someone in the main function. That also we have learned, right? And we have also learned how to pass the pointer to a function, right? So more or less this covers how pointer can be used as the argument in a function. With this note, we'll end this lecture. See you in the next lecture. Stay tuned.